Hey guys, Will here. Welcome back to the channel. Now in today's video you can see beside me I've got my PC kind of in pieces again, and we're going to be stripping it down a lot more than this today, and you're probably wondering why on earth are we already pulling it apart again. Now the reason for that is today we're going to be delidding the 8700K processor. So if you're not already familiar with delidding is the process of removing the integrated heat spreader, or IHS, from the actual CPU die itself and replacing the TIM, or thermal interface material, underneath that with high quality liquid metal, which is what most people use, instead of the horrible plasticine like stuff that, or mayonnaise as some people call it, that Intel uses from factory. What that achieves is vastly reducing the CPU die temperatures. So the reason I'm doing it in this case is because I'm finding that my chip unfortunately needs a lot of voltage to reach high clock speeds. Having to run sort of close to 1.4 volts to get 5 gigahertz stable, unfortunately. So I pretty much lost the silicon lottery, but I thought, why not try and maximize the performance of this chip, get the absolute most out of it. I am pretty confident that I'm hitting a thermal limit rather than a voltage limit. And the reason I think that is because sometimes if I lower the voltage just a little bit to bring the temperatures down, it's actually more stable than when I raise the voltage. So I'm pretty confident I'm hitting that sort of 85 to 90 sort of degree temperature range at a 4.9 gigahertz overclock at 3.4 volts. And that seems to be sort of my sweet spot at the moment. So I'm hoping that by delidding the processor, it will bring my temperatures down enough that I can reach that sort of coveted 5 gigahertz number. Now, it's important to note here, first of all, that delidding absolutely does void your processor's warranty. So if that's a concern to you, don't do this. The real world performance benefits of doing this are very, very, very tiny, if at all. Honestly, in the real world, you're not going to see a difference between 4.8 gigahertz and 5 gigahertz, but I mean, I'm an enthusiast. I love doing this stuff, and you know, having spent the amount of money that I have on this system and all the water cooling gear that's inside it, it seems crazy to me not to, you know, spend that little bit of extra money and take that little extra bit of risk to try and squeeze the absolute most out of it. And typically we see temperatures of around 15 to 20 degree drop by delidding and replacing that thermal interface material. And I've got a couple of other little things that I'm going to be doing as well. So what I've done is I've already recorded a little video showing a stress test and the temperatures and voltages and clock speed that I'm running currently. I'll roll that at the end of the video after we've done the delidding process and show you a comparison between what I had before versus what I will have once the job is finished. So we might even end up splitting this into two videos, one for the installation and process and then one for the result. But we'll see how we go with the video and how long it takes to do. But anyway, look, let's get stuck into it. The first thing I'm going to need to do is obviously drain all the fluid out of this rig. Unfortunately, using hard lines makes it very, very difficult to remove your CPU because you've got to drain all the fluid out, remove the hard lines, block everything up so that it can't leak all over the place. And yeah, it's going to be a little bit of a pain in the ass. Thankfully, if you're using soft tubing or, you know, a normal air intercooler heatsink, then yeah, it's not such a big deal. I mean, what's going to take me an hour here is probably going to take you 20 seconds to just pop the heatsink off and you'll be there. But anyway, we'll get stuck into it. I'll time lapse the process of pulling everything apart because it's not really relevant to this video. But if you are interested in how to drain and refill a water cooling system, do check out my previous video, which I'll link above my head for you now. And of course, if you do have any questions about the process, do let me know in the comments and I will be happy to answer those. So let's get stuck into it. Alright, so getting the graphics card out and all the pipes disconnected without dropping any water was a bit of a mission, I won't lie, but we've got there. There's a little bit of water inside this pipe still, which is a little bit precarious. And I've also had to loosen this pipe at the fitting, and I'm terrified that if I undo this barb from the end of the radiator, it's going to leak more water out. I've plugged up the top here of the radiator to stop any air coming through, so hopefully that won't happen, but we're going to try and do as much as we can without touching anything. I'm not going to move the computer again until I put the processor back in again now. So what we want to do is just loosen off these. We need to pull out our LEDs as well. So pull those out of the fitting, tuck them away. So we're just going to loosen these 2 at a time. And we're going to lift our water block straight up because there's still a little bit of liquid inside it and we don't want to spill anything, so lift it straight up and then release the pin. Lift the flap and remove the CPU like so. Okay, so we've got our CPU and our heatsink, and you can see the thermal compound that I put on in the previous video earlier is spread out nicely. There's no exposed areas of the IHS there, so that's obviously been the right amount of thermal compound. So go back and watch that video if you're questioning how much thermal compound to put on these things. It's all shown in great detail there. Basically the size of 2 grains of rice is all you need for your main heatsink. So what we're going to do is just take some paper towel and just clean off this as best we can using the paper towel, and then we're going to come back and do a second pass in a moment and clean it properly. Same deal with this part as well. Clean as much as we can. Okay, so for the next step of the process, we're going to use cotton tips as well as our RockitCool thermal material remover. We're not going to use the surface primer just yet, but these 2 products are linked in the description below for you as well. If you're wanting to grab those, you can get them from PC Case Gear, which is where I got them, or if you're overseas, not in Australia, you can get them on Amazon using the links below. So that is a really good product, really great for cleaning off thermal material. And we're going to use cotton tips for the rest of it simply because I don't want to scratch up the base of this. As you can see, it's a beautiful mirror finish and we really don't want to mess that up. We want that to be as clean as possible. So we're going to take our thermal material remover, put a couple of drops on, and just using a cotton tip loosen it all as much as possible. And then we can just wipe the remaining off with a paper towel very, very gently so as to not leave any scratches behind. And we'll go over it once more with a cotton tip just to make sure it's absolutely clean. Like so, and that is as good as new. So what I'm going to do is I'm actually going to put that, because I'm pedantic, I'm going to put it inside a plastic bag just so nothing can touch it, and we'll set it aside. Now I am going to actually be replacing the IHS on this processor with a copper IHS that's a little bit bigger to improve the thermal properties even more. We'll talk about that a little bit more a little bit later, but I'll just get this a clean first. Alright, so now it's time to get down to the business end and actually delid the processor. So there's a couple of things that you're going to need for this, and there's a couple of different methods. Some people just use a knife blade to kind of cut the IHS off the CPU. There's great risks there with scratching the surface of the PCB and damaging your processor. So I've gone the proper route, which is to buy a proper deliding tool, and I've gone with the Rockit 88 delid and reliding kit from rockitcool.com.au. So check out the link in the description below. Now, I reached out to them and they very, very kindly provided me with all of the equipment necessary to do this video in exchange for creating the video for you guys. So a bit of a how-to video as well as the results at the end as well. So thank you very, very much to the guys at rockitcool.com.au for providing this. So the kit itself comes with the deliding tool, and we'll take a quick look at that now. So we'll open it up. And as you can see, it's the first time I've opened this up. So take the package apart. So you can see this is a really nice quality piece of kit, nice and heavy and very, very, very precise. It's CNC machined out. Now you can get 3D printed ones, but because the tolerances are so fine with all of this stuff, you really, I think, you know, for the sake of a $500 processor, it's really not worth taking the risk of, you know, doing it the cheap way. So I'm going to do it the proper way. Nice little bag there as well as some stickers. There's a little bamboo cuticle stick as well there for getting rid of the glue, and the realignment tools there and everything. But we'll get into all of that stuff later on as we go. Set that aside just for now. The next thing that we've got is our Loctite super glue gel. Now, this is what we use to actually glue the IHS back on afterwards, and this is the stuff that RockitCool recommends. Now, I do see some people use RTV silicone. That's fine as well, as long as it's a high temperature silicone. That is absolutely fine to use. But when you use this stuff, you only need a little dab of glue in each corner of the IHS to glue it back into position. Now, some people don't even glue the IHS back on, they just leave it, and that's fine because it does clamp down. I'm going to glue it back on in my case though, just because I want to do it exactly the way that RockitCool recommends. So we also have our copper IHS here, which I'll take out of the bag a little bit later on. Now, this is a replacement heat spreader, and it's a little bit bigger than the original one, and they claim that the temperatures come down a further up to 7 degrees with this as well. So I figured why not give it a try as well. The reason for that is it is a slightly bigger surface area. So it's got the same footprint, but you can see on the normal processor, the IHS kind of restricts in, whereas with the copper one, it's a lot bigger. But we'll look at that in more detail a little bit later on. Lastly, we have 2 sets of CoolLab Liquid Pro and Liquid Ultra. So the reason I got 2 is I wanted to do a bit of a comparison between the two, and we'll do that later on. Now, there's a lot of arguments online as to which one is better. This is the product that actually came out first, the Pro, and then this is the Ultra, which replaced it. Now, this one does actually have slightly better thermal conductivity than the Pro does, and it's also a lot easier to work with, they say. But what I'll do is I'll do a separate video later on comparing the two in terms of their ease of use. But for now, we're going to go with the Ultra because why wouldn't you? It's easier to work with and it should perform that little bit better as well. So we'll set the Pro aside. And we have that. So what we need to do now is unbox or unpackage our delidding tool and get to actually delidding the processor. Okay, so we're unpackaged now. The first thing we need to do is slide the little slider all the way back here. So basically what's gonna happen, the CPU is gonna sit in here, this is gonna go on the top, and then when we wind this in, this little slider is actually gonna push on the IHS to the point where it releases it. So it kind of pushes it off, puts pressure on the glue and the thermal material until it kind of clicks. It makes a snapping noise, which you'll hear, and then it comes off, you take the thing off and it all comes apart. So what we need to do is you need to put the CPU into this. Now you can see here there's a little arrow down the bottom there. I'll just bring it up to the camera for you so you can see. A little arrow there. So we need to align that with the arrow on our processor. So if you look at the processor, there's a little arrow just there. So line that up, and you can see there the processor is sitting absolutely flush with that edge there. So that's what we mean when we say it's absolutely precision stuff. Now what we also want to do is just put a little marking on the heat spreader as well, which will come off later on if we want it to, just showing us where that aligns to. It's very, very important that the heat spreader is aligned the same way when you put it back on at the end, otherwise you'll have all sorts of problems. So what we want to do now is make sure that's wound all the way back, put the cap on, and now we want to install these screws. I'm not going to do them super tight all at once, we'll do one at a time. They don't need to be crazy tight, just tighten them down. All right, and now we bring this across. All right, so it's the moment of truth now. I'd be lying if I didn't say I was a little bit nervous, but these are the things that we do. So insert our Allen key. And we're just putting pressure on now. It does require quite a bit of force, and there's the snap. So that was relatively easy. And then all we want to do is undo these screws again. Take off the lid, and you can see there the IHS is loose from the CPU now. So lift it off very carefully. And there we have it. So I'll zoom in and give you a good look at that. So you can see the silicon that's left behind. Now interestingly, there's this little gap at the top just here, and that is actually an air gap. Because of the massive temperature fluctuations that happen with these processors, there needs to be space for the air that's inside between the die and the IHS to actually escape. So there's a little air pocket that's created and the air can escape. Otherwise you'd build up pressure underneath there and that could cause all sorts of problems. So the next step we need to do is clean up all the old thermal material off the die itself and also clean up the glue here. So there's a couple of different ways we can do this. I'll probably start off doing the glue first. I'm going to set my IHS aside somewhere safe for now. We're not actually going to be reusing this one. So using the little cuticle stick that actually comes with this, what we're going to do is we're just going to remove this glue. And it comes off pretty easily. Now because this is bamboo, it's nice and safe. It's not going to damage anything, but don't push in super hard. You can see there it flicked up on me. So don't push in super hard. Just take your time with it. And try not to put your fingers on the actual die there as well, because we want to keep oil and grease out from this as much as possible. So you can kind of just go over it with your thumb as well. Alright, so that's nice and clean for a first pass. Now what we want to do is clean off the thermal interface material that is remaining on there. So we'll grab a cotton tip, and I'm going to try and get this part off like that without using my cleaner, because it's just going to stop it from smearing everywhere. And you can see how easily that's cleaning up, no problem at all. And then I'll use some of my cleaner to clean off around that surrounding area. I'm just going to put it onto the cotton tip. You can see here how careful you need to be not to send it flying across the room. Now if your processor is older, this will be a little bit more difficult, but you can see for me, this processor is only about a month old. It's only been running for a month, and it's cleaning up very easily. Alright, just grab one more dry cotton tip and just run over it very quickly. Okay, so the next step that I'm going to do is optional, but you can see just here there's 4 little contacts there which are electrically conductive, obviously. So what we want to do is, because the Liquid Ultra is actually conductive, we want to mask off that little area there to make absolutely sure that nothing is going to touch that. Now, if you use the right amount of thermal interface material, you shouldn't have a problem, but I have seen other videos where it's pushed out when you've put the IHS back on, spread across, and actually almost shorted out those pins. So I'm going to err on the side of caution and just mask that off. So I'm going to use a little bit of toluene-free clear nail polish that I just stole from my wife. And what we're going to do is we're just going to put a tiny little bit on there just to protect those pins. So it really is going to be the smallest little amount. So just brushing it off there and just dab it on. Across those pins. like so, and then we just need to wait for it to dry. So I'll probably leave it for a good 10 minutes just to make sure it's absolutely dry before we move on to the next step. So we need to make sure that we don't heap it up, because if it's sitting higher than the die is on the CPU, we're going to have problems with the heat spreader not making a good contact. So make sure it's absolutely flat, almost just the tiniest little thin layer over those contacts to make sure that nothing can short up against them. So we're going to let that dry. We'll come back in a few minutes and move on to the next step. Okay, so for the sake of completeness, while we're waiting for our nail polish to dry, I'm also going to show you how to clean the IHS as well, just in case you're not using one of the copper replacement IHSs. So pretty much exactly the same. We're going to take a clean cotton tip again, take off as much of this thermal interface material as we can. And you can see it comes off really easily if the process is relatively new. Didn't even have to use any cleaner to get the worst of it off. If the process is older, it will harden and become a little bit more stiff to come off. But then what we'll do is, again, use some of our cleaner, dab it on in the middle, clean cotton tip, and some paper towel. Clean that up. And then once again using our cuticle stick. Now this time you might want to use the pointy end to actually get it out of the corners like so. And this is a little bit more fiddly than the processor was. But it is very important that we get this cleaned up, because if we don't, we won't get a good contact, because we'll be putting glue on top of glue, and the heat spreader will end up sitting higher than it did previously. So take your time with this as well. All right, and then we'll use a cotton tip once again with our cleaner. And that is our IHS cleaned. Okay, so back to our processor again, and you should be able to see now there's a very thin layer of nail polish over those contacts there, which is going to stop any shorts, and that is now completely dry. So the next step now is to do pretty much exactly the same thing that we just did with the IHS on the rest of the processor here, just with a little bit of our cleaning material. And the reason we're doing that is just to remove any fingerprints that we might have accidentally placed on while we were doing the rest of it. So because we were putting our finger down on it and manhandling it, just want to make sure it's as clean as possible. Don't get it on the area where you just put the nail polish, because it may eat away at that. Like so. So now what we want to do is get our sellotape, which is just the straight sellotape that you get from any supermarket, and we're just going to mask off around the outside of the die so we don't get any spillage when we're putting on our liquid metal. So get enough length that you can easily peel it off again at the end, and simply place it on like that. And this is why we need to make absolutely sure that our nail polish is dry first, because if it isn't, we're going to create a mess. So this goes there. It doesn't need to be stuck down hard or anything like that. All it's doing is just protecting the rest of the CPU. There we go. So before we get into our final preparation of the die, let's have a look at this copper IHS that we're going to be installing. So we'll move that aside quickly. Grab out the copper IHS. So it's in a nice little bag again. Comes with a couple of stickers as well, which is cool. So we'll set those aside for now. Now it comes with a separate alignment tool, which is really important, because if you don't use this, you may have problems with the final alignment when you're putting the heat spreader back on. So we do need to make sure we pay attention to that. All right, so let's unwrap it. Nice. So you can see there the difference in surface area between the two is pretty significant. Okay, so inside the Liquid Ultra packaging, we get a little Scotch-Brite pad, which you can use to clean up your IHS if you need to. A little isopropyl alcohol 70% cleaning pad as well, but we're going to be using our RockitClean once again, and our surface primer this time as well. You also get a couple of little application brushes here, which you'll use to actually spread out the material and the material itself. So what they say is to squirt on the size of a pinhead and then spread it out with the brushes. Now, I've never used liquid metal before, so it's going to be very interesting to see how it goes. I understand that it's quite difficult to clean up if you do put too much on, but the first thing we need to do now is clean up our dye one last time. So we'll use our thermal material remover once more, just to make absolutely sure we haven't left anything behind and that it's squeaky clean. And then finally, our thermal surface purifier. And this is the last step. Just make sure that there's nothing left behind. So don't actually touch the dye. Just dab it on there. Again with a clean cotton tip. Just swab it around and it will evaporate really quickly off there. So we're making sure we don't have any dust particles or anything like that left behind, and that our surface looks absolutely clean. And then we're ready to apply our liquid metal. I'm going to do the same thing with our IHS quickly now too. Use our surface purifier just in case there's any dust or anything in there. So we're just going to put the tiniest little bit of this on. That should be enough. And this is a lot easier to apply than I thought it was going to be based off some of the stuff I'd read online. I'm going to remove the tape now. And now it is time to mount our IHS. So we pop on our jig tool that came with the copper IHS. Click that on, make sure it's pushed down nice and solid. And then we simply drop our IHS into position. Now, it's a little bit confusing on the instruction sheet. The grooves go towards the top. We drop that in. And now what we want to do is just put a tiny little dab of super glue in each corner. We really don't need much here. So it comes out like a little gel. So all you do is you just put a dab in each corner. Just enough to hold it into position, and then we grab our spider tool and we drop that in so screw the legs on. And then just screw the middle bolt in. Now it doesn't need to be done up super tight. Just enough to put a bit of pressure on the IHS. And now we just wait for our glue to set. So it takes about 2 to 3 hours for this glue to set. It's not like regular super glue that dries hard very quickly. Because it's a gel, it does take a little while to set. So we'll just leave that. Now another thing that's a good idea is to put a fan nearby, because the glue does give off some nasty gases that leave a white residue. So if you put a fan on there, it'll expel those gases nice and quickly and stop you from getting problems. So we'll put a little fan nearby as well while the glue dries. We'll come back in a couple of hours and reinstall everything. Okay, so our glue is now dry. So we remove the main bolt here. Remove the spider. And now we can remove the IHS template as well. And there is our freshly relidded processor. So you can see there the difference in the size between the standard IHS and the aftermarket one, or the copper one. So pretty substantial difference there just in surface area, which is the main contributing factor to the difference in performance. So we'll get it cleaned up, we'll get it reinstalled in the computer, and it is time to see how we went. Okay, so we're back up and running. I'm happy to report that there were no issues at all with booting back up and leak testing. Everything worked absolutely perfectly, and I can see already in my graphs that our idle temperatures on the CPU have dropped about 10 degrees straight off the bat. So what I'm going to do is I'm going to leave it at that for this video. I think we've covered a lot of information in this video already, and I don't want to get into the results and make this video too long. So stick around for the next video where we'll be looking at a couple of things. So we'll be looking at the results directly, so exactly the same settings before and after the delidding and what difference it's made, and then we'll move on to what we've actually been able to achieve in terms of furthering our overclocking and undervolting as a direct result of delidding. So do stick around, hit that like button if you found the video useful, hit the subscribe button as well and the notification button so you don't miss that next video, and remember rockitcool.com.au to pick up your delidding kit, or if you're living overseas outside of Australia, you can also follow the links in the description below to purchase these products. But I hope you found the video interesting, and I will see you in the next one. Bye.